Students, in this video I will show you the circuit connection of JK master slave flip-flop. So this is the circuit which we need to follow to construct JK master slave flip-flop. In this circuit has been constructed using only NAND gates. Okay, coming to NAND gates, there are two types of NAND gates. One is 3-input NAND gates, another one is 2-input NAND gates. So here we have three 3-input NAND gates and another 6 2-input NAND gates. For a 3-input NAND gates, I need to use an IC of 7410. 7410 is an IC that need to be used for the 3-input NAND gates. In this IC, there are only 3 NAND gates. So I can use a single IC. So all these 3 gates comes under IC1. Coming to the other 6 2-input NAND gates, here 7400 is the IC number for 2-input NAND gates. Here this is the first 2-input NAND gate, this is the second, third and fourth. All these 4 2-input NAND gates are come under one IC, which means that all these 4 2-input NAND gate comes under IC2 and the other 2 2-input NAND gates are come under IC3. Even for this we will be using 7400 because even these two are 2-input NAND gates. Why we are using 2 ICs for 7400 for this 2-input NAND gate is because here we have 6 2-inputs NAND gates. In a single IC, we have only 4 2-input NAND gates. So the first 4 will be gates will be used in IC2 or comes under IC2 and the next 2 will comes under IC3, which means that I am using 3 ICs on this circuit. Now we will do the circuit connection. So here we have 7410. I will connect this IC to the first IC base. Then we have 7400. We have 2 7400s. I will connect this to the second IC base and I will connect another 7400 to the third IC base. Okay, so now I will take one patch cord. So from the circuit, you can see here from the circuit, I will take up the first NAND gate, that is a 3-input NAND gates. Here the 3 inputs are from, the one input is from Q bar, another input is from J, another input is from the clock. So now I will take up one patch cord here. So I will connect one end of the patch cord to the Q bar. Q bar is nothing but the second output. So this is the second output, logic output. So these are the green pins. These are the logic outputs. So one end of the patch cord is connected to Q bar, that is nothing but the second output. Another end is connected to the 13th pin in the 13th pin of 7410 IC. So here this is the first, second, third, fourth, fifth, sixth and 7th. As we have only 14 pins on this IC, so there are 7 pins on each side. On the left hand side we have 7 pins. So from the bottom right corner, so this is 8 pin, this is 9th, 10th, 11th, 12th and 13th. I will connect this another end to the 13th pin. Okay, now I will take another patch cord. So here according to the circuit, J is the input. J is the first input that is connected to the first pin of 7410. So here one end of the patch cord is connected to the first input, that is J. Another end is connected to the first pin of 7410. Next we can see here 2 and 3. So 2 and 3 are shorted, which means that second pin of 7410 and third pin of 7410 are shorted, and from any one of these pins I need to connect another I need to take another patch cord and I need to connect that to the clock. Before that I will do this connection, that is one end of the patch cord is connected to the second pin of 7410, another end is connected to the third pin of 7410. So see here, I will take this patch cord, one end will be connected to the second pin of 7410, another end is connected to the third pin of 7410. And I will take another patch cord, so one end will be connected to any of these pins. One end is connected to any of these pins. Either you can connect that to the second or third pin, and another end is connected to the monopulse clock. Here in the digital trainer kit we have the monopulse clock here. Another end is connected to the monopulse clock. So next, so for the first gate we have connected all the inputs. Next, I will take up the second 3 input NAND gates. Here I have done this 2 and 3 shorted. Next, the second input, that is a K, that is connected to the 4th pin of 7410. See here, I will take one patch cord. One end is connected to the K, that is the second logic input. Another end is connected to the 4th pin of 7410. Next, here you can see we have another input that is connected to the 5th pin. This is from the Q output. This is from the Q output. So see here, we have one connection that is connected to the 5th pin of 7410 to the Q output. Q is nothing but the first output. So I will take up one patch cord here. I will connect one end of the patch cord to the first output, that is Q. Another end is connected to 5th pin. Another end is connected to 5th pin. So now I have done this input connections. Next, I will take up the third IC, where the third gate, NAND gate. Even this third NAND gate is 3 input NAND gates. Here you can see the pin numbers 9, 10 and 11. All these 3 are shorted, and from any one of this pin that should be connected to the clock. Okay, now what I will do is I will short these 3 pins 9, 10 and 11. So now I will take up one patch cord. One end is connected to the 9th pin. So this is 7th. From the bottom right corner, this is 8th and this is 9th. So 9th pin is connected, one end of the patch cord is connected to 9th pin. Another end is connected to 10th pin. And I will take up another patch cord where one end is connected to the 10th pin. Another end will be connected to the 11th pin of 7410. Now I have shorted all these 3 pins, that is 9, 10 and 11. Now I will take up another patch cord. I will connect one end to the monopulse clock. Another end of this patch cord can be connected to 9 or 10 or 11. You can connect another end of the patch cord to either 9 or 11 or 10. So I will connect another end to the 9th pin. Okay, so now we are done with the input combination for input. We have provided the input for all these 3 input NAND gates. Now moving on to the second IC, where second IC has 4 2 input NAND gates. I will take up the first 2 input NAND gates. Here the first input is from the 7410, that is IC1 12th pin is connected to the first pin of 7400. See here, so this is 7410. Here one end of the patch cord is connected to the 12th pin. So this is 7th, 8th, 9th, 10th, 11th, 12th pin. Another end is connected to the first pin of 7400, that is IC2. Next, you can see here another input for this 7400, that is first 2 input NAND gate is from the 6th pin of same IC 7400, that is the same IC. So what I will do is I will take up one patch cord. One end is connected to the second pin of 7400 IC2. Another end is connected to the 6th pin of 7400 IC2. So see here, I will take one patch cord. So one end will be connected to the second pin of 7400 IC2. Another pin is connected to the 6th pin of 7400 IC2. So this is 6th pin. Okay, so now, we have given the inputs for the first 2 input NAND gate. Next, second 2, I will take up the second 2 input NAND gates. So here you can see one connection that is connected to the 4th pin of 7400 from the 3rd pin of same IC 7400 IC2. So here we have IC2. I have connected 7400 on the second IC base. One end is connected to the 3rd pin and another end is connected to the 4th pin of same IC, same IC2. And we have another input combination that is that should be connected to 5, and that is from the 7410 first IC 6th pin to the second IC 5th pin. So I will take up one patch cord here. One end will be connected to the 6th pin of first IC. Another end is connected to the 5th pin of IC2, that is 7400. This is how we need to give the input connection. So now Moving on to the third 2 input NAND gate that comes under IC2. Here the inputs are from 10 and 9 and the output is from 8 pin. I will take up the first input, where the first input is from the third pin of IC27400, that is connected to the same IC, that is IC2 10th pin. Okay, so I will take up one patch cord here. So one end will be connected to the third pin, another end is connected to the 10th pin. So this is 7th. So we have only 7 pins on the left side, another 7 pins on the right side. From the bottom right corner, this is 8, 9, 10. So I will connect another end of the patch cord to the 10th pin. Okay, so now we have another input. See here, the 9th pin and the 13th pin of same IC are shorted, and from any one of this pin that should be connected to the 8th pin of IC1, that is 7410. Now what I will do is, I will do this short connection. I will short these two connections, which means that I will take one patch cord. One end will be connected to 9th pin of IC2 7400. Another end will be connected to the 13th pin of IC2 7400, which means that 9 and 13th in IC2 should be shorted. So one end will be connected to 9th pin. So this is 7, and from the bottom right corner this is 8, so 9th pin. I will connect one end to the 9th pin. Another end will be connected to the 13th pin of same IC. So 7, 8, 9, 10, 11, 12, 13. This is 13. So another end I have connected that to the 13th pin. So from any one of these 9th or 13th pin, I should connect that to the output of 7410 8th pin. Okay, so one end of the patch cord is connected to the 13th or 9th pin. I will connect one end of the patch cord to the 13th pin. Another end is connected to the output of 7410, that is 3 input NAND gate 8th pin. So here 8th pin is under IC1, so this is 7 and this is 8. See here. So I have connected like this. Next, what I need to do is, we are done with these 4 2 input NAND gates that comes under IC2. Moving on to the IC3. So in IC3 we have only 2 2 input NAND gates. I will take up the first 2 input NAND gates under IC3. So here we have 2 inputs. One input is connected from the 8th pin of IC2 to the first pin of IC3. See here, one end is connected to the 8th pin of IC2 to the first pin of IC3. So both are same ICs, 7400, 2 input NAND gates only. Next, another input is from the 6th pin of same IC, that is IC3, which means that one end of the patch cord is connected to the 2nd pin of IC3, another end is connected to the 6th pin of IC3. See here, one end will be connected to the 2nd pin of IC3, another end is connected to the 6th pin of IC3. Next, moving on to the last 2 input NAND gates. Here again we have 2 inputs. One is from the 3rd pin of IC3. So one end should be connected to the 3rd pin of IC3. Another end is connected to the 4th pin of same IC, that is IC3. So I will take one patch cord. So one end will be connected to 3rd pin. Another end is connected to the 4th pin. Okay, next we have another input that is from the 11th pin of IC2, that is connected to the 5th pin of IC3. See here, I will take up one patch cord here. One end will be connected to the 11th pin of IC2. So this is 7, 8, 9, 10, 11. Okay, so 11. Another end is connected to the 5th pin of IC3. Okay, so next what we need to do is, so the output is from this IC3740 from the 3rd pin, that is connected to the Q, that is connected to Q. Okay, so here IC3, so one end of the patch cord should be connected to the 3rd pin of IC3, another end is connected to the Q, that is nothing but the first output. See here, one end is connected to the 3rd pin, of IC3, another end is connected to the first output, that is Q. And next I will take up another patch cord where one end of the patch cord should be connected to the 6th pin of IC3, another end is connected to Q bar, where Q bar is the second output. See here, I will take up one patch cord here, I will connect this to the 6th pin, another end is connected to the Q bar. Okay, so next what I need to do is I have not done the VCC and ground connection. In all these three ICs, 7th pin is connected to ground. Okay, all these three ICs, the 7th pin is connected to ground and 14th pin should be connected to VCC. Now for the third IC, I will connect one end of the patch cord to the 7th pin, another end is connected to ground. Now I need to do the VCC connection. So I will take up one patch cord, 14th pin is connected to the plus VCC in all the three ICs. So we have left out one connection here. So that is I need to connect one end of the patch cord to the 6th pin of IC2, another end is connected to the 12th pin of IC2. Same IC, one end of the patch cord is connected to the 6th pin, another end is connected to the 12th pin. So I will take up one patch cord here. So one end will be connected to the 6th pin of IC2, another end is connected to the 12th pin. So now we are done with the connection of JK master slave flip flop. Now we need to verify this circuit. Now we need to verify this circuit by this truth table. Okay, so in this truth table we can see there are two inputs. You can see in the circuit diagram, as we have only two inputs, that is one is J, another one is K, and we have two outputs Q and Q bar. So as we have two inputs, so we have four input combination truth table. So we have four input combination truth table. In the first input combination, in the first input combination, J is equal to 0 and K is equal to 0. So if I give J is equal to 0, K is equal to 0, then output will be Q is equal to 1 and Q bar is equal to 1. And status of that input combination is the flip flop. The JK master slave flip flop status is in hold state, which means that there will be no changes in the output. And next, moving on to the second input combination, that is when J is equal to 0 and K is equal to 1, Q is equal to 0, the first output is 0 and Q bar is equal to 1, and the status of JK master slave flip flop will be in reset mode. The third input combination is 1 0, that is when J is equal to 1 and K is equal to 0. So for that the output is Q is equal to 1 and Q bar is equal to 0, and the status of JK master slave flip flop is in set mode. And the last input combination is when J is equal to 1 and K is equal to 1, and the status of the JK master slave flip flop is toggle, which means that both the outputs will get toggle. Now we will verify this truth table. Now we will verify this truth table on the constructed circuit. Now we will verify this truth table on the constructed circuit. So here we have constructed the circuit on this digital trainer kit. Now after doing the connection, what we need to do is we need to switch on this trainer kit and we need to provide the inputs through these switches. So as we have two inputs, so these are the two yellow pins. The first one is J and the second one is K. So first one is J and the second one is K. So here both the switches are in low state, which means that J is equal to 0, K is equal to 0, and the output is Q is equal to 1, Q bar is equal to 0. That's what we have in this truth table. So here in this truth table we have J is equal to 0 and K is equal to 0, and the outputs are Q is equal to 1 and Q bar is equal to 0, which means that when I give a clock pulse, there won't be any changes in the status. See here, this is the monopulse clock. So I will give the clock pulse here. You can see there is no changes in the output. The output will be in hold state, which means that the JK master slave flip flop is in hold state even when I give the clock pulse. I will take up the second input combination. Now I will take up the second input combination, that is 0, 1. For that I should get Q is equal to 0 and Q bar is equal to 1, and when I press the monopulse clock, it should reset, the flip-flop should reset. Now I will set the inputs as J and K, where J is equal to 0 and K is equal to 1 here. Now I will give the monopulse clock. See here, Q is equal to 0, which means that no light will get emits on the LED, and Q bar is equal to 1. Q bar is equal to 1 here. So even when I press the monopulse clock, so now the flip-flop, that is a JK master slave flip-flop, is in reset mode, because in reset mode the output Q is equal to 0 and Q bar is equal to 1. Now I will take up the third input combination, that is when J is equal to 1 and K is equal to 0, the output should be Q is equal to 1 and Q bar should be 0, and when I give the monopulse clock, the status of the JK master slave flip-flop will be in set mode. We will verify this now. So I will set the J is equal to 1 and Q is equal to 0. For this, when I give the monopulse clock, you can see here the output where Q is equal to 1 and Q bar is equal to 0, which means that the JK master slave flip-flop is in set mode. It has been set to Q is equal to 1 and Q bar is equal to 0. Now we will verify the last input combination, that is when J is equal to 1, K is equal to 1. So in this input combination, when I give the clock pulse, the output should toggle. See here, now J is equal to 1, I will give the input as J is equal to 1, which means that I will turn this switch to the high state, and I will turn the K switch to the high state, which means that both the inputs are in high state, and the value of this is J is equal to 1 and K is equal to 1. Now when I give the clock pulse here, the output should toggle. The output should toggle, which means that when I give the clock pulse here, see here, Q is equal to 0, Q bar is equal to 1. When I again press the same clock pulse, now the output is Q is equal to 1, Q bar is equal to 0. This is how the output will toggle when I give the monopulse clock.
To execute this program, so we need to open Xilinx ISC 8.1. So double click on this. When you double click on this, the application will get open. Now what you need to do is, so we have already one project that has been opened here. File, close project. Click on close project. Okay. So after closing the previous project which has been opened earlier, now what we need to do is we need to create our own project. We need to create a new project. After creating a new project, then what we need to do is we need to create a file and we need to type our program in that file. Okay, so to create a new project, go to file, click on new project. So when you click on this new project, a dialog box, create a new project, a dialog box will get open. Now here we need to give the project name. So I will enter the USN number. So or you can give anything. Project name can be anything. So I will enter a 4VM19 here. Then click on next. So again click on next, click on next, click on next again, and at last you need to click on finish. So after this, so now we are done with creating a project. So we have created a project. You can see here the 9. Under that we have a project structure. Select this project structure, right click and select new source. Now what we are doing is we are creating a file. So in this file, what we will do is we will type the program. So okay, so now after click on this new file, so we need to give, so first you need to select VHDL module here, because the program what we are executing is a Verilog HDL program, is Verilog high definition language. Okay, so now we need to give the program name here. So I will enter a program name as JK flip flop. JKFF. Okay, you can give anything, but don't give the same name for project as well as the file name. So file name and project name should be unique. It should be different. Okay, now click on next. So here what we need to do is we need to give the input and outputs. So we need to enter the input and output ports in JK master slave flip-flop as we have discussed in the previous video. So we have three inputs. One is J, another one is K, and the third one is clock input, CLOCK. Okay. So next we have two outputs as we have discussed. The first output is Q. Second output is Q bar. So I will type QB. Okay. So Q and Q bar are output. So here you need to select it as output direction. Okay, so here what we are doing is we are defining a module. In this module we are setting the port names. I have used J, K and clock as input ports, and I have used the QB and Q bar as the output ports. Next, so what I need, so here you can see, so here I have represented J as input, K as input, clock is also as input, but Q and QB are as output pins. Next, click on finish button. So after click on this finish button, now you can see here below we have a JKFF. So this is the file which we have created. Click on this JKFF. So here we need to type the program. So here you can see there is an entity with the port names. We have a J as input standard logic, K as input standard logic, clock as input standard logic, and Q and QB are the two outputs that is output standard logic, and we are ending the entities. So after ending the entities, the program will start from architectural behavioral of JKFF, which means that whatever the program we write under this begin, so this entire architecture behaves on that. This entire architect, the port numbers, that is port JK, clock, Q and QB. So these ports behaves on the program what we write the begin and end. For the time being, I will just copy the program. Okay, so this is the program. Program has been explained in the other video. So just I'm showing the execution. Just I'm showing that program execution here. So after typing the program, what you need to do is you need to save the program first. Okay, so here we have a save button. Click on this save. After saving the program, next thing is you need to check whether is there any errors in this program. We need to compile the program. We need to compile the program. So to compile, what we need to do is select this JKFF. After selecting this, go to the process window. Under process window, we have one option called synthesize XST. So click on this plus sign before synthesis XST. So when you click on this plus sign, you will get one option called check syntax. Double click on this check syntax. See here, we have one error that is on the line number 40. So on line number 40, we have one error. We need to solve that error. See here in line number 40, I have typed begin twice. So I need to remove one begin. Okay, now I have made some changes on the program. So what I need to do is again I need to click on the save button. After click on the save button, again I will double click on this check syntax. See, now the program has been successfully compiled with 0 errors. Next, what I need to do is I need to set the waveform for this. So to check this program, whether it is correct or not, so I need to set the waveform for this. So let's see how to set the waveform. So click on this JKFF. Okay, click on this file where you have typed the program. So select that file under source window. After selecting that file, right click on that, select new source. Here, select a source type, a new dialog box will get open. Under that, you need to select test bench waveform. So here I am creating a file to set the waveform. Okay, so select a test bench waveform, and here you need to give the file name. So here I need to give the file name for setting the waveform. So I will keep JKFF bench. Again, you can give anything as a file name. Okay, click on this next. So again, click on the next button. After that, finally click on this finish. So here, after when you click on this finish button, you will get clock initialize there. The initial timing and clock wizard. Initial timing, here you need to select GSR FPGA. After selecting this, here you need to select a combinational or internal clock. So these are the two things which you need to select in this window. After selecting that, click on finish. So after click on that finish, here you will get a window where we need to set the waveform for here. So we need to set the waveform. Here you can see we have three inputs. One is J, another one is K, and the third one is a clock, which means that we need to set the waveform for only these inputs. And based on these inputs, the outputs will behave. That is Q and Q bar will get behave on these three inputs. Now, as I discussed earlier, so this a blue colored one is usually represented as high, and the white color one is usually represented as low. Okay, in a single waveform, we will be having both low and high. So this is one waveform, that is the blue colored one and white colored one. Both will becomes one waveform, which is nothing but so this becomes one waveform here. Okay, before setting the waveform, I will show you the truth table of JK master slave flip-flop. See, so yeah, this is the truth table of JK master slave flip-flop. We need to use this truth table to set the waveform. Okay, so here in this truth table, we have two inputs. One is J, another one is K. And we have two outputs. One is Q, another one is Q bar. Okay, when J is equal to 0, K is equal. So the J value, under J, we have two zeros and two ones. Under K, we have 0, 1, 0, 1. So there are four input combination here. First input combination is 0, 0. Second is 0, 1. Third one is 1, 0. And the fourth one is 1, 1. Now I will set this in the waveform. See here, 0, 0, 1, 1, 0, 0, 1, 1. Okay, so let it be 0, 0 only. Okay, so here I have set this is one waveform, 0, this is second 0, and this is first one, and this is second one. Next, for K, 0, 1, 0, 1, again it will comes to 0. Okay, so now I have set J as 2 zeros to 1, and I have set for K as 1, 0, 1, 0, 1. Next, I will set the another input, so I will again repeat this input combination. That is, I will set J is equal to 0, 0, 1, 1. So this is 1, 0, second 0, 1, and 2 ones. Now again, I will repeat for K as well. So it is 0, 1, 0, 1, 0. So here I have repeated the input values for both J and K. Now coming to the clock, I need to set it to 0 or 1. So you can only see the output only when the clock is in high state. Okay, you can see the output on JK master slave flip-flop only when clock is in high state. So I will set the clock in such a way that, so the first waveform of clock will be 0, and third will be 0, fourth will be 1, and fifth will be again 1. I will set like this only, and sixth will be 0, 7th will be 1, 8 will be 0. After that, again, you will set it to 1. See here, clock, what the input combination what I have given for clock is, first I have given 0, next 1, next 0, next 1. After that, again I have repeated as 1, 0, 1. Next, what I will do is, so based on these inputs, we need to see whether we will get the correct output or not. We need to see whether we will get the correct output or not. Okay, so moving on to the truth table, moving on to this truth table. So here I will write another input, that is clock. Okay, you can only see the, you can verify this input combination only when clock is in high state. If a clock is 0, then no need to verify the output. So we need to verify the output only when clock is in high state, which means that only when clock is equal to 1, we need to see the output. Okay, so now I will, when j and k are equal to 0 0, and if clock is equal to 1, I should get q as 1 and q bar as 0. Now I will show combination in the program. Okay, so here I will save this waveform. First, I will save this waveform. Next, I need to see the behavior of this waveform, right? So here under source window, select behavioral simulation. After selecting that behavioral simulation, you need to select the file, that is you need to select the file where that file is where you have created the waveforms. Okay, you need to select that waveform file. After selecting that, here you need to come below. So here you have a process window. Select this process window. So after selecting this process window, you will get one option called Xilinx ISC simulator. Click on this plus symbol. Under that, you have two options. You need to double click on this last option, that is simulate behavioral model. Double click on this last option. Wait for some time. Yeah, so this is the output. This is the correct output. Now we need to verify this waveform whether it is correct or not. So now what I will do is I will go to the test bench. I will, under markers, I will select this single marker. So I will put the marker here. So in this, you can see here, J value is equal to 0, K value is equal to 1, and clock is 1. If clock is 1, I can verify the output. If clock is 0, I cannot verify the output. That is, I cannot verify Q and Q bar if a clock is equal to 0. Now, I have a now clock is equal to 1 in this. So the input combination is J is equal to 0, K is equal to 1. What's the output I'm getting here is Q is equal to 0, QB is equal to 1. Let's verify with the truth table whether we are getting correct or not. See here, the second input combination, that is when J is equal to 0, K is equal to 1, the output is 0 and 1, and it will be in reset state. So see here, for 0, 1, we get outputs as 0, 1. See here, for J is equal to 0, K is equal to 1, we got output as 0, 1. Now I will move this marker here. So here you can see here J is equal to 1 and K is equal to 0, which means that we cannot verify the output because clock is 0. Next, I will move the marker here. So here you can see the value of J is equal to 1 and K is equal to 1 and clock is equal to 1. We can see the output. For 1 and 1 in the truth table, it should toggle. So here we cannot show the toggle on this waveform. So the output is 1 0. Let it be like that only. So this is correct only. Okay. For 1 and 1 combination, it should toggle. So we are getting, for 1 and 1 input combination, we are getting 1 0. No need to worry, it is correct only. So after that, I will move this marker here. So here you can see the value of J is equal to 0 and the value of K is equal to 0. Clock is equal to 1. What's the output I am getting? Q is equal to 1. Q bar is equal to 0. Let's verify this output. See here, when clock is equal to 1 and when J is equal to 0, K is equal to 0, what's the output I am getting? Q is equal to 1, Q bar is equal to 0. That's what I am getting here. When J is equal to 0, K is equal to 0, and when clock is equal to 1, I am getting Q is equal to 1, Q bar is equal to 0. Now I will move this marker here. So here J value is 0, K value is 1, but clock is 0. The output here. K is equal to 1, K is equal to 0, clock is also 1. Now we can see the output because clock is equal to 1. So here, for this input combination, that is when J is equal to 1, K is equal to 0, what's the output I am getting? Q is equal to 1, Q bar is equal to 0. We will verify whether we are getting the correct output or not. So the third input combination, that is when J is equal to 1, K is equal to 0, the outputs are Q is equal to 1 and Q bar is equal to 0. The status of that is in the status of JK master slave flip flop is in set mode. That's what we are getting here. When J is equal to 1, K is equal to 0, and when clock is equal to 1, if clock is equal to 1, I can see the output. So I'm getting the output as a Q is equal to 1, Q bar is equal to 0. So that's what it has been mentioned in the truth table. When J is equal to 1, Q is equal to 0, K is equal to 1, Q bar is 0. We are getting the correct output. So this is how you need to verify whether the waveform which we got from the program is correct or not. So this is the program which we have written. For this program, we are getting this waveform. So like this, you need to verify this waveform whether it is correct or not by referring this truth table. Okay, so this is how we need to simulate this program. So we are done with the simulating the JK master slave flip flop. If you